I gonna be famous?
Let's talk about compound interest. This is your compound interest formula. That right there means the amount. That right there means the principal or starting amount. Principal means starting amount. I think it's LE. That's the principal. This right here is the rate. It's the annual rate. Annual rate. This right here, N, is the number of times compounded per year. And T is the number of years. Okay, those are all your variables in the compound interest formula. So we're going to take
When am I going to use that formula?
Anytime you're going to use that formula, anytime you do investments or your banking, anything like that. Anytime they tell you about, like, it's typically used in investments, banking, that kind of stuff.
Chrome has
okay,
vanished.
so here we go. I've got this set up right here. So what we're going to do is I'm going to calculate I'm going to show you guys through a quick example of how compound interest works. Because here's what's going to happen. You're going to go to the bank, and one bank's going to say, hey, we will compound it one time per year. In other words, every December 31st, we will take a look at how much money you had on average in your bank account, and we will give you, let's say, 5% of that interest back, because they take your money that you let them keep and they lend it out and they charge even more interest. That's how banks make money. Okay? Another bank's going to say, oh yeah, I'm going to compound it every year. In other words, I'm not only going to give you 5% at the end of the year, I'm going to give you half of what you would have earned in the middle of the year, and that way whatever you would have earned is going to compound interest for the last 6 months. Other bank's going to come along and say, oh yeah, I'm going to compound it every quarter. In other words, every 3 months. I'm going to compound it every 3 months instead of every 6 months, which means that your money will work for you even better, etc., etc. And here's what that looks like. Here's an example. Let's say that the bank has an annual rate of 5%, and we're going to calculate the total amount in your bank account after 10 years if the principal is $1,000 based upon these different number of compoundings per year. Okay? So to do that, I've already set up the problem for you. You plug this into your calculator very carefully. Notice what I've done. Each time the only thing that's changing is the number of compoundings per year changes. Okay? So let's calculate these. Go ahead and do it in your calculator. Punch them in and see if you get the same numbers I get. So notice I computed the first two. Notice that if I put $1,000 in at 5% interest for over a 10-year period, I'm going to earn a total of $628.90 in interest over 10 years from that initial investment of $1,000. $1,000 investment invested, I gained over 10 years $628.90. Notice that when I changed it to twice a year, if I'm combining it twice a year, I made $10 more by doing that, because my number right here is roughly $10 more than my number right here. All right, I want you to make a prediction. What do you think the number is going to be if you compound it double that? In other words, 4 times a year. What do you think the number is going to be? Notice that you might be shocked to find out that this was only $5 more when I doubled the number of times. It was only $5 more, not $10 more over a 10-year period. That's a little shocking. All right, what's the prediction now? What if I triple that last one? In other words, I'm going to compound it every month. Notice I'm compounding it monthly, 12 times a year. How much more money will you have than if you compounded it only quarterly? Go ahead and compute that right now. So notice that time it only increased by less than $4. I tripled the amount of compoundings per year, but it only increased by $4. What's happening here? This is crazy. All right, let's try one more. What if I compound it every single day? I'm going to compound my money every single day. See, what's happening is the 360 on the bottom, the 360 is kind of working against the 360 up here. So even though I'm raising it to a much higher power, this fraction is really becoming smaller and smaller too. Because 0.05, that interest rate, I'm splitting up 360 times, which means that's going to be closer to the number 1, right? And if I raised 1 to a power, What does raising 1 to a power do? Nothing. It's still 1. So the closer this number gets to 1, the less important it is that this is bigger. And that's really what's happening here. So when I did this, my answer was 1648.66. So notice it only increased by like barely $1.50. That's how much it increased by. And when I compounded it, almost every day, I know it's not quite daily, but 360 times a year is almost every single day I compounded it. So what's the point? Well, the point is there's a natural limit to this number right here. And that natural limit is this. Amount equals P, whatever the principal is, times E to the RT. That formula is called continual compounding. And you're going to see it. We're going to do it right now. So let's calculate what's the amount going to be if I put $1,000 in the bank at a rate of 5% over 10 years. What's that equal? Sorry, I forgot. I put 100, but it should be 1,000. Your answer is 1,648 and 72 cents. Look how close it is to that. It's only 6 more cents. So what am I saying? I'm saying that if I put this number, if I made that number a million, a billion, cajillion, a Google, if I make that number bigger, it's never going to get bigger. This number right here, the compounding, is never going to get bigger than this number right here. And there's proofs for that. I'm not going to prove it to you. But that's the whole point. So this formula right here, these are the two formulas you need to know for interest, compound interest formula. This is the continuous compounding. And this one right here is the compounding, the finite compounding, if you're compounding it n times. And that's how those two numbers are related.